Hi everyone, it's Damien for another video. Didn't work last, I don't know, probably 1 week. Yeah, probably it's been 1 week I didn't work. Oh, yeah, pretty much 1 week. I did do a session with my mentor and we came up with that solution, which I didn't really want to explain because I wanted to go on another exercise. But yeah, I can explain it because I actually understand it, even though it's been what? Yeah, it's been 1 week. I did it. Oh, I didn't actually watch it, but my mentor watched it. And yeah, so you remember my solution was that. So basically, we were um, trying to see the different how many characters was different between two strings, which is in a context of yeah by oh my god, biological stuff. Sorry. Which is a strand one and a strand two, and the number of nucleotides that are different are called the Hamming distance. So by biological stuff, that's in the context of biological stuff, this is how it's called, the Hamming distance, which is in a strings, purely technical, it's just how many characters are different between two strings. And the strings has to be the same length. So this is what I come up with. So you can see it was 7 days ago, and I come up with sort of two solutions. So the first one is actually using an index and counting how many characters are different using those index in in the different strings. Then I found that this one, line 9, where I'm still using the count method, but I'm actually zipping the two string. So we have a big array within, yeah, a big array where there is um, arrays between, no, sorry, arrays within the big one, which, so let's say there is a big array, and inside that big one, there is smalls one, which is at size or length of 2, and which is the first character of the first string and the first character of the second string combined, sort of. So this is what the zip method is doing. And after that, so I have a pair basically here, and I compare each pair. Not really. Yeah, I compare each element of the pair within the big array. Then the other solution was using the reject method. So it's pretty much the same as this one. The only exception is that I don't use the different, I use equal. So I reject the string, um, not the string, the characters um, that are equal, and then I have the ones that are different, and I just return the size of the array because this reject method return an array, and I do pretty much the same here. You're still using the reject method, but I'm using the zip method so I can do the same sort of calculation on the pair. And so I submit that, and I said to my mentor that this is what I did for the Hamming exercise. And we had a session, and we come up with that. He first told me that I didn't necessarily have to use an index because, well, we don't really care about the index. We just want to compare the nucleotide. Sorry, I mean I don't know how they call it. Sometimes they call it. I know the first version it was called the nucleotide, and now it's called nucleic. I don't know why, nucleic or something. So yeah, so basically, he told me that I didn't need to use an index. Sorry, so I should basically use that part here, put it right here, and just count. I mean, just see the difference between the two different characters. So this is what we did here. So we're using basically just don't care about the other code here. I'm zipping the two characters, right? The two strings, sorry. I get a nucleotide. Then I got a setter, a getter here, which is actually here. And I call that getter, and I count um, how many, yeah, how many characters that are different. And I'm just using N1 and N2, and we know we are talking about the nucleotide here. So this is actually much more, like, I would say, readable. Even though at first I didn't really understand it because you have to, like, to put yourself in the, I mean, yeah, you have to say that Ruby is kind of doing a lot of things for you, because for me it was obvious to use an index because you have to know in which character you were, in which part of the array you were. But Ruby handling it for you so pretty well, and that's fine. Now it's sort of obvious that way, even though it's still, if I if I see some code like that, I guess I will understand, but probably not at first. I will have to think through and say to myself, yeah, I done that before, and I will remember it. So yeah, and after that, what we basically did a class Hamming, where we have an initialize method where we put the string 1 and the string 2, or the string 1 and the string 2. We're raising an error if the size of the strands are different, and we create a class method for that. Sorry, we create a class for that, for the error, so which is here, and which is pretty simple. And then we have, yeah, we calculate, not really calculate, we zip the strings together, which is a nucleotide. This basically, like I said, this will basically give you something like, you have your R, oh sorry, you have your arrow here, and you will have stuff like that. So you will have probably something like, um, oh, I cannot type, okay. You will have something like that. Uh, Come on. You will have this, U and O there, and you will have, actually you will have that, and you will have this, and I don't know, B, and what else, this and this, this and this, and let's say B and B. So here, for example, so when you do the zip in the nucleotide here, you will have something like this, and after that you do the count. So the count is basically going to compare each element here. So n1, n2, n1, n2, and 1 and 2. And for this example, the Hamming distance will be of 2, because you can see that this one is different as this one, and this one is different as this one, and those are equal. So that's it pretty much. I'm just gonna remove that. I mean, I basically have to do that. And then what we did, because the compute method is not really, like, when you think about it, the compute method is not something like related to that class. It has nothing to do with that class, nothing, like, it's not really on the context of that class. It doesn't really belong there. So we just did a module where, like the module name said itself, convenience method for Hamming. And we extend the Hamming class with that module. And we are able to, because now we are extending the class here, the Hamming class. So when we are here, we're still into the Hamming class, so we are able to do this, to create a new instance of the Hamming class, and then call the distance method here. Because this module is now a part of the Hamming class, it's like you're adding behavior to that class, basically. And that's it. And because it's a method of the Hamming class, even though it's separated within a module, but actually extend by this line here. So you can call Hamming dot compute, which is what the test is doing, and it's actually working pretty well. I mean, I can show you. So here's the Hamming stuff, and if I do Ruby, no, you can see that everything is working fine. So that's it. I'm gonna comment this, and so that was yeah, 1 week ago, basically. What's going on with Git? Why does it take so much time? Git status. Well, okay. So we're just gonna, I'm just gonna see the change here, but I think I know what the changes are. Basically, we just change the whole thing. Git diff, yeah. So we had that, we have, yeah, those was the class before. Yeah, the class before. So yeah, git had or git commit. How can I like it's not really right. Yeah, it's right, but it's like create, yeah, create. It's not really create, but like provides a modular or more. And let's say we find Hamming class. It's not really like, yeah, let's go that way. Git push origin master. So that's it. I'm gonna close this one so I can put it on YouTube, and then I will start another one which will be related to the other exercise. Thanks for watching, guys.